today we wanted to, on behalf of Tuum Technologies, we wanted to hold a webinar for everyone who is interested in learning about everything that has to do with decentralized identities. And if most of you guys are familiar, but we have had our decentralized identity sidechain on Elastos for the last year and a half, actually almost 2 years now. It went live in July of 2018, and it has gone through a lot of improvements, a lot of modifications, and pretty recently in December of last year, 2019, we actually upgraded the DID sidechain to conform to the W3C specifications. So there's a lot of stuff going on. So I thought it would, we thought it would be a good idea to hold this webinar so we can educate people who are not familiar with DIDs, how they work, and we do have some demos here today that we'll be showing. So we'll get started here. So the title of the webinar is How to Add Decentralized Identity Login to Any Application. So let me just go through the next slide here. All right, so on the agenda today we have, I'm going to talk about introduction to Elastos, what's Elastos DID, and I'm going to give a brief intro to Elastos. Lot of confusing names here, but I think through the end of the seminar webinar, you should be able to figure out the differences between Elastos, Elastos DID, and Elastos. That's our flagship product. And then there's 3 demos here. There are, we're going to take a brief look at those later. All right, so first things first, I would like to introduce Elastos to those of you who are not familiar with Elastos or need a quick refresher on what Elastos is, what it's trying to do, and how we differentiate from other platforms, other blockchain technologies out there. So to sum it up, actually Elastos, there's really no easy way to summarize Elastos in a sentence or even 2. So I'm going to do my best here, but stay with me. Elastos is a new smart web platform that is aiming to solve the problem of double spending for digital assets in the same way that Bitcoin solved the problem of double spending for currency payments. So we're trying to do the same thing for digital assets, right? So what do we mean by that? Well, that actually involves 3 different pillars, we like to call them, of Elastos. The first pillar is our Elastos blockchain, and our Elastos blockchain is actually a multi-layer blockchain compared to other blockchain platforms out there. We have our own main chain that actually does the payments of ELA tokens, and then we also have side chains structure. So we have the main chain and the side chain structure, where we have different side chain dedicated for different purposes. For instance, we have DID sidechain that is dedicated to the decentralized identifier sidechain, and that's what this webinar is about. That's what we're going to talk about today. But there are also other sidechains, and we're not going to talk a lot about those, but there are those to keep in mind. So there's Ethereum sidechain that is a fork of the public Ethereum blockchain, which means that any sort of smart contracts that you have on Ethereum blockchain, you could actually easily migrate those and have them run on Ethereum sidechain of Elastos. And that gives a couple of benefits here. First of all is scalability and also security. And I'm not going to dive too much into that. We will probably have more seminars webinars in the future. And then there's also token sidechain. There's Neo sidechain for that can run Neo smart contracts. Theoretically, we could actually have more sidechains in the future. So in order to get any of the sidechains into Elastos, obviously now that the Cyber Republic consensus is live, it would have to be proposed first and it would have to be voted on. and it would have to be passed, and then the team could work on it. And then, if tomorrow there is a sidechain, for instance, for Ethereum 2.0 sidechain, maybe we want a new sidechain for that just to make things easier, right? So there needs to be the proposal that needs to be passed, and then once everything's approved, the core team can then work on adding a new sidechain for Ethereum 2.0. So that's just one of the examples. There's a lot of benefits to having this main chain sidechain structure, but one major thing is to silo everything so that you are only using a specific sidechain for the given purpose and nothing else. That kind of decouples everything when it comes to development side of things, as we'll see later on. Our second component of Elastos is Elastos Carrier. That is our end-to-end encrypted peer-to-peer communication layer. This is completely different to the blockchain layer because those are two completely separate peer-to-peer networks. Blockchain is on a kind of network that is dedicated for one specific purpose, and then Elastos Carrier is another network that is dedicated for another specific kind of purpose. And Elastos Carrier, mostly it is used for communication. So when you're talking about if you want to have completely end-to-end encrypted communication, for instance, for chat messaging, that's one of the great examples. There's a great application, Hyper, that already utilizes Elastos Carrier for this chat messaging system. There's also, it can be utilized in the IoT industry. So if you wanted to build your own smart home, or even integrate Elastos Carrier onto any of the existing IoT devices, Internet of Things devices, then you could theoretically use Elastos Carrier and you would have end-to-end encrypted solution, and all of that works actually, the security is by default rather than as an afterthought. That's what we like to say with Carrier. And then last but not least, Elastos Hive. Elastos Hive is a little different because it is not really a network per se. It's more of an interface that connects to different networks, more specifically the storage networks. For instance, you can use Hive to connect to the public IPFS network, and there is an SDK available already, and you could utilize Hive SDK to interact with the IPFS network. You can store your files, whatever you want to, on IPFS network, and you can easily retrieve it later, and all of that is stored in a decentralized manner. And then you could also use Hive, this interface, to interact with your own personal cloud drive. Or in the future, there is an upgrade to Hive, Hive++, that is coming out. That will be an interface to interact with what we call vaults. I'm not going to go too deep into what vaults are, but the idea is vaults are pretty much your personal cloud drives, which is used to store all your personal data, all your application data, and all your blockchain data. So that means whenever we roll Hive++ out, whenever Vault is introduced, whenever it's on its stable release, that's when we can truly leverage the entirety of Elastos platform, what it provides. Because only then you'll be able to say to other people that, hey, I actually own my own data, because you will own your application data, you will own your personal data, you will not need to store it on any other servers or other companies. Like, companies can build their applications and they could utilize Hive++, and then where you are going to be storing your own data instead of companies storing your data on behalf of you. So that's the major difference there. All right, that's the brief introduction to Elastos. Move on to the next one here. I'm gonna talk a little bit about how our blockchain works here. So the idea is, one thing I forgot to mention is our Elastos blockchain is actually merge mined with Bitcoin, or it can also be merge mined with any of the other SHA-256 coins out there, which means that currently we're leveraging the enormous hash power of the Bitcoin network itself, which leads to our own network being very, very secure. And in order to penetrate the Elastos network, you would have to gather enormous amount of hash power. But in addition to that, not just merge mining, but also we have our own DPoS, Delegated Proof of Stake Consensus. So it's a mixture, it's a hybrid of merge mining plus the delegated proof of stake consensus plus the Cyber Republic consensus. So it's an amalgamation of all three of these consensus working together to form this Elastos blockchain network. So that's what this is talking about. You have all these transactions that are mined by the Bitcoin, Bitcoin merge miners that are then signed by these delegated proof of stake nodes, and then eventually they get to the block and are added to the blockchain. So that's what that is. I'm going to talk about a little bit about this. So I talked about sidechain structure, but the way that it works is you can't really generate coins for these sidechains out of thin air. What ends up happening is, let's say you wanted to utilize various capabilities of that DID sidechain offers, right? So in order to do that, first of all, nothing is free on blockchain. So which means that it's going to cost you some amount of money. In this case, you would have to pay an ELA. So which means that in order to utilize any of the capabilities of the DID sidechain, if you wanted to interact with the blockchain, then you would have to first transfer your ELA from the main chain to DID sidechain, and then utilize the DID services there. Or if you wanted to execute some Ethereum smart contracts on Ethereum sidechain, you would have to transfer some ELA from the main chain to the Ethereum sidechain, and then you can spend that there. So in a way, all the ELAs that are in all of these different sidechains plus the main chains, that is the total circulating supply of Elastos ELA token. So which means that all of these ELA tokens are circulated back and forth between different sidechains, from main chain to sidechain to main chain, so on and so forth. So as soon as you transfer some ELA from main chain to sidechain, I don't want to use the term locking, but essentially you're locking that ELA on the main chain and then unlocking it on the sidechain. So until you can get it out of the sidechain first, that ELA cannot be taken out of the Elastos ecosystem. So in a way, the more of these sidechains there are, the more of these services that are offered in these sidechains, the more ELAs on these sidechains are utilized, the more circulating supply is going to decrease for Elastos, the actual circulating supply. So that's the tokenomics a little bit here, but basically the ratio is 1 ELA to 1 ELA sidechain tokens for any of the sidechains out here. And this one here talks about like different purposes for different sidechains here. DID sidechain we're going to talk about today. That looks at how you can have like your verified KYC, your know your customer verifiable credentials that anyone can verify, authentication. Your token sidechain can be used to create fungible, non-fungible tokens. Neo sidechain again to execute Neo smart contracts, and then you can have other custom sidechain, and then you have Ethereum sidechain for Ethereum smart contracts, and so on and so forth. And excuse me. You can use, and all of these are actually indirectly protected by merge mining. So every services that utilizes the Elastos ecosystem, it is indirectly secured by the enormous hash power of Elastos network, which is last I checked, it was over 50% of the Bitcoin hash power. So that's how these are the main chain and side chains work. All right. Today we're going to talk about Elastos DIDs. DIDs stands for Decentralized Identifier. So before we talk about all the cool things you can do with DIDs, let's talk about the problems that we're trying to solve with DIDs, Decentralized Identifiers. So a lot of the problems today in the existing traditional world is that a lot of the identification systems are centralized, which means that you have your Facebook, you have your Google sign-in, you have your Twitter, you have Spotify, you have a lot of these silos where you have to remember your password, different email address that you use to sign up on their websites, and then your user data is then stored on their database, and that is controlled by those said companies. For instance, all your data, all your login credentials, all your authentication, all of that is being protected by Facebook. Now that could be seen as a good thing or a bad thing, and we'll talk about that in a little bit, but basically the idea is, the main point that I'm trying to get across is that the systems for the identification identifiers are very, very centralized. There are these intermediaries, and you don't know what they're doing with your data. They might be selling it to third parties, they might not, who knows, but they might be. There is always that risk. Or even if they're not selling it to third parties indirectly, in case their server gets hacked or something like that, then your data could actually be compromised. So that's one of the main problems. So in going along with that, you're also forced to trust the commercial internet services. So when you sign up on Facebook, you're trusting Facebook to trust your data. And when you're sending a private message on Facebook, you're trusting Facebook to not reveal your personal messages to some random third party. You're putting that trust on these internet service providers, right? And then company collects user data, sells data to third parties, or doesn't secure data properly. So even if a company is good, they don't want to sell your data, chances are they might not be securing your data properly. And even internet giants like Facebook have had hacks before, so it's not out of the realm of possibility of something like that happening. Just because a company is huge, they have enormous power, resources behind it, doesn't mean that the services that they use to protect your data are also secure by default. That is just not the case. And last but not least, individuals do not have control over their personal information. Now, I could actually choose to not reveal my actual name to Facebook, actual gender to Facebook, actual age to Facebook, which, I could do that. I could have an anonymous profile and I could just, have lots of friends there. I could talk to anyone and it would be okay, right? But just imagine a scenario where you actually have to submit your personal information. For instance, any of the banks logins or any of the cryptocurrency exchanges, when you have to withdraw some cryptocurrency transactions, crypto out, you have to provide your real name, your personal information. You have to be verified, sort of going back to that KYC, know your customer, compliant. So all of these, there's always that risk in the back of your mind that what if tomorrow the exchange that you've been using suddenly shuts down, or suddenly your data gets leaked. You just cannot be sure. So in short, you do not have control over any of your data at the moment. So what is Elastos DID actually offering to solve? Elastos DID is actually offering to solve this exact problem, these problems that I just mentioned, by offering its unique solution. One of those is basically, the first of all is issuing identities by the blockchain itself. So instead of Facebook issuing your ID and then they're storing on their database, instead of Google issuing their ID and then storing on their database, you can create your own DID and then record it on the blockchain, transact with it on the blockchain. So technically you would be the owner of your identity, which is a completely different way of thinking about it, because it is a very decentralized way of creating your identity. And it is under complete control of the user itself, in other words, you. So you can do whatever you want with it. Tomorrow you don't want to use that identity, maybe it has been compromised, easy enough, you can deactivate the DID so that in the future no one can read any sort of documents that are attached to that DID from that point on. So there's a lot of potential there. And then there's no companies or intermediaries or third parties involved in storing personal information. So there's a couple things we're going to look at later, but the idea is with DIDs, there are no companies that are storing your identities. There are no companies that are storing your data. Rather, it's just you who has control of your private keys, your mnemonics, and then you can choose to store the application data, your personal data, your blockchain data on your own personal cloud drive or on the blockchain or IPFS or whatever it is that you desire. And applications can request user for their DID and automatically verify particular personal information without having to collect and store the data. So this goes back to the idea of, okay, there are some websites like bank websites or exchanges websites that you have to submit your personal information, because otherwise they can't just allow you to withdraw withdraw cash, right? So in case of that, you could actually create a decentralized identity, and then you could have it be KYC verified using DID. And so from that point on, other applications can retrieve that DID, can ask permission to verify whether the age that you claim to be is legitimate or not. And they can do this without you having to reveal your actual age. So application, maybe, you require, on some applications, we require people to be over 18, right? But I don't want to reveal my actual age. Like, I don't want to reveal that I'm 28 or 40 or whatever. Well, that's where DID comes in. These applications can integrate DID capabilities so that they could ask whether this person that this DID is owned by is at least 18, is over 18. And that's the check that can be performed. So in that way, the applications don't ever receive how old you are. Rather, they just know that you are over 18, so they don't care. And that's the benefit of having a DID. All right, this is just visual representation of what I talked about here with DIDs. In the traditional world, there is Google ID, Facebook ID, Microsoft ID, and you have to keep track of these 3 different IDs individually for different platforms, and it's just a mess, right? Where we're going to this new paradigm here, where I have one unique DID or multiple, it's up to me, and then I can use Google Chat, I can use Facebook Chat, and we can use the chat system. These chat systems can utilize the same DID to talk to each other, and they can be interoperable because there is no Facebook database, there is no Google database. Rather, it's just the blockchain that is the data that works as the database, or something else, right? So then it can work as sort of that authentication layer. So you can just have this DID sign-in capability on Google.com or Facebook.com or whatever. And that's exactly what this webinar is about. Like, we're going to show some demos here how you can easily integrate DID login capability to any of the existing websites out there. That's the power of decentralized identities. All right. So again, I talked about this, but you might be wondering, well, why would I even use Elastos DID, right? There are many other DID platforms that are out there, like Microsoft or whatever else. There's a major difference, actually. First of all, something like, centralized entities can also have their own DID platforms, but chances are they either work on a permission blockchain or they are completely private. So even if they do utilize the various standards, various specifications for these DIDs, how much of those platforms are actually secure? Well, we can actually claim our security because this DID platform of ours, Elastos DID Sidechain, is secured by the merge mining hash power itself. So all of the data that you generate using DIDs are actually, you can be guaranteed that as long as there are these merge miners mining it, your data will always be secure. It will be that much more computationally expensive to do anything with this database. It's a blockchain, but I don't want to call blockchain a database, but we're going to be using blockchain instead of a traditional database for authentication layer. Now, you can't use blockchain for everything, but for authentication, it's a perfect use case. Benefits of Elastos DID. So a user can choose to publish verified DID credentials to the blockchain, or they can just store it in their own device. Now, this is the number one thing, actually, that you can do. This is especially prevalent inside Elastos, the application that we're going to look at later. But the idea is, well, I don't want to store my actual age on the blockchain. That's fine. You can just get your DID verified through some third party, your age, right? And then you can store it in your own device, or you can store it in your own personal cloud device without having to store it on the blockchain. And then applications can utilize Elastos identity application to request to verify your age without having to go to the blockchain. They can just utilize the DID credentials without ever interacting with the blockchain. Now, that's if you want to remain private. In some cases, what usually ends up happening is for a lot of cases like supply chain, things like that, you do want to store it publicly, right? So that way, for those kind of things, you do want to store those DID credentials on the blockchain. So there are use cases for both private use cases for how to use DID and public use cases. Next thing is brings data ownership back to its owners. We talked about this, where instead of third parties like Facebook, Google, owning your data, everything, rather it's you who's going to take back that ownership. So you are in control of your data. You can deactivate your DID whenever you want to. You can add additional document. You can verify more. You can add more credentials. Like I want to add my university diploma that I have graduated with a bachelor's degree in computer science on the blockchain, and I can do that, and I can get it signed from my college, right? And then in the future, instead of, let's say, like whenever I get a new job or something like that, they request my college transcript. Well, they don't, usually in the traditional world, I have to talk to my college, get the transcript, forward it to my employer. That's a mess. Rather, if you were to use DID for these verified credentials, the employer can just get my DID and check the DID document of my verified diploma on the blockchain. They can verify whether that is signed by my university, and all of this can be verified publicly. So the employer would be immediately able to tell that the diploma, the bachelor's degree that I received, is actually legitimate in a matter of minutes, which is a great advantage. All right, so tamper-proof identification for everyone. We talked about that. Secured by merge mining. We talked about that. Independent proof of ownership. So you are in sole control of your own data, of your own identity. KYC, verified digital identity, where the user controls who to share the data with. Again, there's two kinds of KYC verified digital identities. Like some applications may actually require your actual name, and they could do that. But other cases, like I gave earlier, like they just want to verify that you're over 18, or they just want to verify that you live in the United States. Well, I don't have to tell them where in the United States I live, or I don't have to tell them what age I am. I can just let them verify my DID that I am at least 18 years old. I am in the United States. So all of that can be done without me revealing any of my sensitive, private, personal information. And last but not least, interoperable with other DID platforms that also implement the same W3C standard. So there is actually, I think there's over 50 or 100 different platforms that are also implementing the same DID with that conforms to the same standard that we have, like Microsoft has it, GitHub, Ethereum has it. So any sort of credentials that you get on Elastos, you can actually just take it to somewhere else and then publish it on their platform, and it would be entirely legitimate. You don't have to redo that process all over again. That's what being interoperable means. You can have these documents be stored on your own DID on multiple platforms and be able to verify using any of these platforms out there. All right, live since 2018. All right, some of the use cases here, I wanted to talk about this a little bit. So the idea, let me see here. All right, so there are a lot of use cases. We talked about some use cases, but I'm going to talk about some other use cases here as well. One of the first use cases is online shopping. Now think about this for a second. Right now there is thousands and thousands of marketplaces online where you shop, right? And maybe you want, you're purchasing some item from a website, and then okay, I want to buy a phone. Okay, I'm buying a phone, I get it delivered, but then upon delivery, I don't get the same phone that was advertised on that website. Well, that sort of problem, there is really no solution right now. Now imagine if we were to tie that kind of, tie that in with the use cases of DID. What we could theoretically do is we can actually validate the legitimacy of that online listing. So any of the items that these marketplaces put on their website, for instance, the phone that I was looking at, it could have a unique digital identifier, and then it could have a lot of information on the blockchain. It is verified, it is signed by the actual manufacturer, everything like that, and I could check it publicly. All of those would be able to be verified by me rather than just trusting this third-party marketplace. So by doing that, you're kind of solving a problem that you knew was there but never really got around to it for when it comes to online shopping. So when I buy something online, I want to be sure that I get the actual item that I purchased rather than the advertised item which might not be the same one. So that's the number one thing for online shopping, right? Vehicle assemblies. So when it comes to vehicle assemblies, I'm talking about different parts to manufacturing a vehicle. As you can see, there's lots and lots of different parts when manufacturing something like a car, and each one of those parts, each one of those components have to be verified that they are actually, they have gone through security audits. They have to pass through some certain compliance, and all of those, it's a waste of time for the car manufacturers to be able to go back and forth just to verify all of these components are actually legitimate. What if we were to get all those components, get them all unique DIDs, and get the DID documents on the blockchain, and then the manufacturers can then look at the assembly QR code and be able to verify everything from the blockchain automatically. So it just reduces the time from the development to the market when it comes to vehicle assembly. And this is, I talked about manufacturing of a car, but it can be applied to any sort of assembly related manufacturing, honestly. All right, third thing is encrypted data vault. This is actually one of the number one thing which Elastos is also working on right now with its Hive++ vault. So, traditionally, as we were talking about earlier, all your personal data, everything for Facebook is stored on the Facebook centralized server. And just recently, actually, Zoom was accused of not using end-to-end encrypted solution when it comes to their video platforming service. All of this kind of data, we have to trust these third-party companies who provide us these services. What if there's a way to actually encrypt, even if you're to give permission to Facebook, even if you're to give permission to, Zoom or whoever else to store your data on behalf of you, what if there's a way for you to use your DID to encrypt your data in someone else's database? That would be a big thing, because that means that even if someone were to store your data, as long as they don't have your private keys, they will not be able to access that data. And this becomes huge in terms of like the use cases of the applications that can be utilized. For instance, Elastos is currently working on developing Hive++, which is an interface to Vault using DID. So, we could utilize DID authentication to log into this Vault. We can store any sort of personal data, application data, any sort of data that belongs to the user on that Vault using DIDs in a completely encrypted manner, so that even the end user, you can't really tamper with that data, because like, let's say for Academy app, since you're familiar with it, you don't want to, like, if I were to store all my application data, that means that I would be running my own database for Academy app. Well, I can't allow, like, I can't just give myself like certain amount of points, right? Because you can't do that. That would be all of that. The certain action for that could be could only be triggered using the DID of Academy app, whereas certain other actions could be triggered by using the user DID. So there's a lot of use cases there when it comes to encrypted data vault. Verifiable credentials, we talked about this. You can have a university diploma, a doctor's certificate on the blockchain or not, and then other applications could easily utilize this capability easily. Sharing personal data without revealing personal data. All right, that's one thing. So there's a lot of like data mining that's going on the internet. What if you could actually submit your purchase history, your age, your gender for their own, for this third-party data mining company that wants to use your data, but you don't want to give them the personal information like your name or stuff like that. Rather, you can just give them the purchase history, age, gender without revealing your name. Well, that is possible with DID, and the data mining company can actually pay you to purchase that data off of you. So it just opens up a lot of those kind of use cases. Supply chain anonymity. So a lot of cases actually, when it comes to supply chain, manufacturers maybe don't want to reveal certain items like serial numbers to everyone in the world, and because in fear of their competitors trying to do something similar. So you can use DIDs to anonymize certain identities where you can just let other people verify that it was manufactured somewhere else without revealing all the intricate personal private details about the particular item and that supply chain. So that is huge. Decentralized corporate identifiers. So when it comes to corporations, maybe you want to store tax identification numbers, legal entity identifiers. There's a lot of use cases like that. It could be used in that scenario as well, to communicate the unique identity of an organization without revealing any of the other information, right? Prescriptions. This is huge when it comes to healthcare. Because what if I don't want to reveal my condition to the pharmacist, but I would be having my interaction with my doctor, and my doctor would sign a prescription using my DID, using their DID. They would sign and then sign me a prescription, and then I would just take the prescription to my pharmacy, and then by scanning the QR code, they would just give me what I need instead of having to ask me what problems I had or something like that. Digital executor. When it comes to law, there's also a lot of things there. For instance, will. Whenever you could actually have with these DID, the W3C compatible DIDs, you can actually make it so that in case of your death, you could actually trigger an action whereby all of the assets that is owned by you under that particular DID, the ownership of all those assets is transferred over to someone else, to your relative. This can already be done, and that is a huge advantage of using something like DID in relation with like smart contracts. And then single sign-on, that's more for signing everywhere using one sign-on using DID. That's more for security purposes. All right, we're running out of time here, but I have some demos, not much to go through, but I wanted to introduce Elastos, because there's a lot of confusion there. Elastos is a project name. Elastos is a product name. That is our product that is available on Android, and it will soon be available on iOS, and in the future it will be available on desktop. But this is an app browser that utilizes the entirety of Elastos technology. So it uses Elastos Carrier, which we talked about earlier. It utilizes the smart contracts in the future. It uses DIDs, which is a big thing. It uses Hive, all of those things, right? The number one thing is when you build applications, what are called capsules inside Elastos, there are no more websites. There are no more IPs. There is no more centralized control. So these are really the true decentralized applications that developers have been, wanting to build, but you can do so using Elastos today. And developers can quickly create Ionic apps using Angular or React, and that can run inside Elastos. So that's what we're gonna talk about today. Build decentralized applications within a matter of minutes. So over the last few months, there's been a lot of improvements on the development tools, developer tools, and things like that when it comes to developing applications for Elastos. So a lot of those will have been pretty easy, and documentation is there for everyone to look at. So that's that. The way that Elastos browser works is this is the Elastos browser inside, and there's different plugins available: DID plugin, Carrier plugin, Hive plugin, Web3.js plugin, SPV wallet plugin. all of these plugins, they're just interacting with different things, right? DID plugin is interacting with DID sidechain. The SPV wallet is interacting with main chain, Ethereum sidechain, Elastos Hive storage, and then there's also going to be a DApp sidechain in the future. And then Elastos browser just lets developers easily interact with all these plugins, which indirectly means that they are building on top of these platforms indirectly without having to. I don't need to know how the main chain works in order to implement a simple payment solution inside my capsule. That's what Elastos browser is doing. I don't need to know how DID sidechain works in order to implement a decentralized identity, in order to provide decentralized identities to other users in my app. So that's what Elastos browser is. And this is the developer lifecycle. What happens is you build an Ionic application first, utilizing different plugins. You, as a developer, you have your DID, you have your Ionic application, you then verify using your DID. Again, goes back to the verifiable credentials. You generate an EPK, which is an Elastos package, and then it will be sent to right now it's being sent to the centralized App Store server, but in the future it will be completely decentralized, and all of the metadata will be stored on the DID sidechain itself. And then the Elastos browser then retrieves the application and automatically downloads it, installs it, and it's available to the user. So that's the workflow. That's the life cycle of Elastos. All right, so I'm just gonna show this demo. There's no audio here, but I'm just gonna quickly go through this. I think the next couple slides are about demos, and then we'll wrap it up. I didn't want to show a live demo because usually in my experience live demos almost never work. There's always something that goes wrong, so I pre-recorded everything here, so we're just gonna go through this here. So I'm gonna play this. So this is how you would install Elastos. It's very, very simple. So let's see here. So the first thing you go to is Google Play Store. Type in Elastos, obviously, and then it's by Trinity Tech Limited. You install the application. Looks like we have over 10,000 downloads so far, and you download that, you install it, and then think of it as a browser. So when you install it, so you open it, you select your language. It's going pretty fast here, but you're basically creating your identity, your mnemonics here, and then you just go through this onboarding process, and you only have to do this once. So you generate the password to be used in the future to access your identity, and there it is, your identity. When you click on the identity, then you go through the onboarding process again, and then here you go to the identity application. You can check your credentials here. You can add more information like your gender, whatever else if you wanted to, email, Telegram name, all of those kind of things, and then you can save changes, and then there are your credentials. So that's how easy it is to generate a decentralized identity, and that didn't even take me a minute. Well, this video was fast forwarded, but it should be very simple. So that's the whole idea with this. All right, let's move on to the next demo here. This is actually integrating the DID login from another capsule inside Elastos. We talked about Elastos. This is an actual application that's running inside Elastos browser, and it implements the DID login. The way that it works is it actually integrates the DID login. It interacts with the identity application inside Elastos, gets the appropriate credentials, and then uses that to authenticate into this capsule. So let me go ahead and play that. So again, this is from a developer perspective, but basically I'm just installing the Trinity CLI package here. Let me fast forward that a little bit. All right, and then you install, and all of these are available on GitHub, and our last slide will contain the information related to this, but you basically install it, right? And then the only thing you have to do is to test it locally. You just execute this command, and then after a while, go here. It's gonna take a while. I'm just gonna fast forward this a little bit. All right, and then it deploys to my phone here. And then demo capsule, that's the capsule that was just deployed. This is the Elastos browser inside. And then the sign in with DID capability is integrated here. So then this asks for the different information that I filled out earlier, and then it's protected by the fingerprint login. So then this information here, the DID, name, email, all of that is actually, I didn't have to fill that out. I just got that from DID, identity application, automatically. And that's the whole process of how you can, how easy it is to integrate like DID login from another capsule. All right, now we're gonna take a look at the last demo here, DID login from a website. So this, before I go on to this, this is a traditional website. Like you can integrate DID login to Facebook.com, Google.com, whatever. This is just a demo website that we have implemented here. So we'll just go through this. So, and again, all the instructions are already there. So this is just installing the virtual environment here. You just change all the appropriate, and then you just run the script here that is set to automatically do that. Starting the server, and then the website is available on port 8000. And then I go there, and this is the landing page. So then I have this login with Elastos DID implemented functionality. It's the same login capability from inside the capsule. Again, this is the phone here. This is this QR code. What I'm doing here is I'm scanning the QR code from using my scanner inside Elastos. I'm scanning this QR code, which will then automatically retrieve the credentials, this Pachai Sav, my email address, and it retrieves it automatically here, as you can see. And then from that point on, I can register on this website. And that's how easy it is to integrate a DID login registration. And this actually sends it to my the verification link. This is an extra step that is also part of the demo here, but to activate that that link. And then the next time you try to log in, we'll see here in a couple of seconds here. So I'm going to do the same thing here. Go to my scanner app, try to scan this. So that now that I'm registered, as soon as I scan this, it's going to automatically again ask for my credentials, and then after I accept, it's going to log me in. So as you can see, this is a completely passwordless login. There is no password involved here. It's all related to the DID, and you can store anything here, and all of this is already available today. So you can do that. All right. Last but not least, last slide is the summary. So let's briefly recap on what we talked about here. So we have these identities issued by the blockchain, decentralized identities. You can log into any application using DID, and you can only share only what you want with the application. One of the possible use cases we talked about is KYC verified DIDs that can be used to log in without the user providing their real name or age, while the application can verify the name and age are legitimate. Example, a cryptocurrency exchange, like they need to verify your name, your driver's license. All of those could be actually part of the DID verifiable credentials. And then those cryptocurrency exchanges can just integrate the DID retrieval process, and then the document can be retrieved, and then they can verify that you are a legitimate resident of the United States without them having to know who you are, what your name is, what your age is, any of that information. You don't have to reveal any of that. That's the main advantage of something like KYC verified DIDs. Possible use case, use different DIDs to log into different applications. That's also a use case. And then use DID for encrypting data before sending to another person. That's also another use case. All right. In today's demo, we actually didn't show a DID login from an external native applications. We did show a demo from inside Elastos, like one of the capsules from traditional website. And then there's one more demo that we wanted to show, but no time here, but we will put it on GitHub, where you'll be able to integrate DID login from any of the existing native applications like your Android or iOS. So you can integrate DID login from anywhere, from any website, from any application in the world. So that's the future there. And one of the things that we're working on as Tuum Tech is we talked about how important those KYC verified credentials are, and that's what Vouch application is all about. We're working on providing this capsule inside Elastos that lets you validate your DID with real world data. So one of the first applications that we'll have is you'll be able to put in your email address, and then you can use our application to generate these verifiable credentials. In the beginning, Tuum Tech will be the one providing this service, but I can easily see like other third-party providers If you want to partner with us, you can be one of those third-party providers providing these services. You can sign someone's email address is legitimate, and then other applications in the future, okay, maybe maybe they don't trust Tuum Tech for verifying someone's email address. Well, but they do trust maybe someone else, right? So applications could integrate complicated, sophisticated use cases like that with utilizing Vouch application. So that's what Vouch is. Assist application, that's another application that we're working on right now, capsule inside Elastos. It will actually let you generate multiple DIDs with the same mnemonic. This feature was available before on Elastos, but no longer. But with Assist, this will be available, not immediately, but in the future, it will be available. So then it'll also allow you to publish DID documents for different DIDs for free. That's what Assist is. So we're just going to assist people in publishing those DIDs. And then far future, I guess, Android, iOS native versions for both Assist and Vouch. We are going to be releasing the capsule version of Assist and Vouch inside Elastos, but the idea is because they're Ionic applications, we can easily port them outside of Elastos, so we can provide them as native applications and have them be available directly on App Store. So that's the far future. All right, well, that's the end of the presentation here. I hope you guys enjoyed it. We'll see if we have any questions here. I'm just gonna go through the chat here. Let me see. All right, questions. Feel free to put some questions here. We'll end the webinar in 3 minutes or so. Looks like, okay, let's see. Looks like we have some. Really don't see any questions, which means that, oh, look at that. Interested in marketplace use case. It can even be used with medicines, drug supply chain, example, vaccines to counter the medicine drugs. That's a great point, Wakas. There's just a lot of use cases, and the use cases that I covered here don't do it justice. There's so many use cases that you can, that is out there. And Shash was asking Microsoft DIDs for building access control. Yeah, Microsoft DIDs, they also conform to the same W3C specification. But again, like, it's a matter of trust, right? Who would you trust in interoperability? Maybe there are some services that Microsoft offers, and then you get those verifiable credentials, and then eventually you publish them on Elastos, and then from that point on you'll be able to utilize it. Because when it comes to DIDs, it's your data. Like, you should be able to be the owner of that data, instead of, even if someone else does offer the DID services, who is actually storing the data, right? Is it publicly available? Is it not? So there's a lot of things that you have to consider when it comes to utilizing DIDs. Enable services like gyms, hotels. Yeah, absolutely. All right. Well, how does it handle sessions? So it is actually a protocol. It is at the protocol layer. It does not actually handle sessions. So the website example that you saw earlier with the DID login, I had to implement the session, handling of session variables, all of that from myself on the client side. So, when it comes to security, you would have to do that at the application when it comes to accessing it from the traditional website. When we're talking about a capsule inside Elastos, all of that is already sandboxed, so the security is built in. But if you wanted to access it from outside, there's a lot of factors involved. Like, of course, like, you can have everything be encrypted. So, theoretically, you could utilize Elastos Carrier to transfer all this data back and forth between different machines, between different people. So you could do something like that so that it is completely secure. And this is just one use case, right? Can you re-explain how you can log into Facebook with Elastos DID and them not being able to use that data? That was an example I gave. You actually can't log into Facebook with Elastos DID. Facebook would have to integrate Elastos DID login mechanism, and I very much doubt they would do that. But if you're thinking about something like Spotify, let's say Spotify integrates DID login in the future. So instead of using, and then they also you want to utilize Hive plus plus, the vault capability, right? So Spotify could technically, the only thing that they would need to do is handle the logic, and then all the personal data, all the application data, all of that would be stored on the vault side, on the personal cloud drive. So that's how that would work. If Bank of America added DID login, would I be able to log in with my Elastos DID, or would they first have to accept verification from a service like Vouch? So that's a tough question. Depends what you mean by if Bank of America added DID login. Like they could add DID login, but how would they add that, right? They would still need to support the retrieval of DID login somehow. And if Elastos supports that same mechanism, that theoretically you could use Elastos to log in. But Vouch is actually not required service. It's a complementary service. So if let's say you want to start a new bank account tomorrow. I'll give you a cool example here. You want to start a new bank account tomorrow, but then that bank needs to know everything about you. But what if you already have your DID, your verified credentials, that has been verified by legitimate third parties that do your real name validation, that have your credit history, all of those, right? You have it as part of your credentials, and all of that is signed. So then Bank of America could, well, not Bank of America, but that new bank account that you're about to create, you could easily create a new bank account, and all that would need to be done is that bank would have to look at the DID credentials, automatically retrieve it because it is signed legitimately, and that process, instead of taking days or hours, it would take minutes. Not even minutes, it would take seconds. That's the kind of change that we're talking about here. All right, well, I think that's it for the questions. Oh, yeah, that's it for the questions. Well, I hope you guys enjoyed it. We will put this up on our YouTube, but good to see you.